This is a demo of AlignEval. But when you first visit the page, you're going to see this pop-up over here. This pop-up sort of explains to you what AlignEval does. AlignEval is a prototype app, which is framed as a game to try to help you build and optimize LLM evaluators. There are 4 simple steps, which is to upload some data, we'll label it, we'll then evaluate it, and then we'll optimize our LLM evaluator. So first, we'll choose a CSV file. Over here, I have a demo CSV file. When we upload it, we mainly get to the labeling novice training grounds. Over here, we label our data. The goal here is to label at least 20 data points. And you'll notice that we cannot even write an LLM evaluation prompt, not write any criteria. We want you to look at your data before starting to write any evaluation criteria. So I'm going to go ahead and label this right now. Okay, I should mention that this data is from the factual inconsistency benchmark, and we have a link on the intro page about what the factual inconsistency benchmark is. Essentially, we have a news article, and for every news article, we have 2 summaries, and one of it is a passing summary, which has no hallucinations, and the other one is a failing summary. After we've labeled 20 samples, we see that evaluation mode is unlocked. So in evaluation mode, this is where we are able to write our evaluation prompt. So we can write our evaluation prompt based on what we've seen in the data, and the prompt should only focus on a single aspect and return pass or fail. So over here, I've written my prompt, which is to evaluate if the output summary contains factual inconsistencies with respect to the input news article. And if it's factually inconsistent, which is a fail, we want to return a 1. And the failure is the positive case here because we want to track recall and precision based on failure. Otherwise, we return a prediction of 0. So before we get down to it, we can also choose our LLM model we want to use. Over here, I'll just stick to GPT-4o mini, and we can also choose the input and output. For most tasks like classification, summarization, or question answering, we need to consider the output together with the input. Nonetheless, there may be certain tasks whereby we only want to consider output, such as considering the style of the output or the voice of the output. So I'm going to just click on evaluate. You see that when we click on evaluate, immediately it starts evaluating. We get to see the LLM explanation as well as its prediction. And if it's a match, you can see that the cell is highlighted in green. And if it's a failure, whereby it does not match what we've provided, you see that it's highlighted in red. Wow, the LLM is actually doing pretty well. Recall and precision is pretty high at 0.88. And you can see we get real-time metrics as the LLM evaluation is carrying on. But you can see sample size stops at 20. That happens because we've only labeled 20 data points. In evaluation mode, it also says that if we want to unlock optimization mode, we need to label and evaluate 50 rows of data. So that's what I'm going to do. When you're labeling the additional rows of data, you can now look at the LLM explanation, and hopefully this makes it easier for you to label the data as whether it passes or fails. Don't let what the LLM has provided affect your judgment on whether it's actually correct or not though. But in this case, it does seem to align. As we are labeling, we get real-time feedback in the top right corner on how many more labels we need. Now we're done labeling 50 rows of data, and you can see it says optimization mode unlocked. Now we are in optimization mode, and all we have to do is click the optimize button. But before that, let's take a look at the metrics. So we have recall at 84, and precision is 0.75, and overall F1 is 0.79. So given this current evaluation prompt and these models, we're going to start optimizing. What happens during optimization is that in the backend, we split the data into 2 halves. We split it in the development split and the test split. The development split is where we use to build our new LLM evaluator. And then we iterate this over 10 trials. After 10 trials, we then take the best LLM evaluator that we have and evaluate it on the test split. Because our sample sizes are so small, we only have 50, what happens is that the results could be variable between the dev and test split. This is because we may have overfitted onto the dev split. To make this more stable, I recommend just increasing the number of data points that you have. In AlignEval, it actually suggests 100 samples, but personally, I would do this with 200 or 400 samples. The key thing to remember is that we want to balance our data between 1 and 0 labels and try to improve our data diversity. And of course, at any point in time, we can mouse over the prompt and you see what is the prompt generated, and just copy the prompt, and that will just copy it to your clipboard. Okay, we can see some examples whereby the initial F1 was 0.64, and then it gradually went up to 0.69, and then 0.68, and then now it's at 0.72. To be clear, this dev split is not quite the same as the total split. For trial 0, we're usually using all the data. The data may not exactly align. It looks like the best F1 we're going to get is going to be 0.72. Let's just wait for trial 10 to finish, and then let it run on the test split. Okay, that's it for the demo. Wow, this is a surprising result for the test split. In the dev split, we got a F1 of 0.72, but when we ran it on test split, F1 jumped up by 0.78. This is a great example. Our evaluation on the dev split and the test split actually can vary significantly. And in this example here, we only have 25 samples in the dev split and 25 samples in the test split. To get more stable results, what we should do is to label more data. Alright, that's all I had. Thank you.